tutorial. In this video, we learn about geometric distribution, its definition. Let us see the introduction. Suppose we have a series of independent trials. We have a series of independent trials. In each trial, the probability of success P remains same. We have n independent trials, and in each trial, the probability of success remains the same. Then the probability that there are X failures preceding the first success. Then the probability that there are X failures preceding the first success is given by P into Q power X or Q power X into P, where Q is equals to 1 minus P. So in this scenario, the geometric distribution is defined. You remember that? Suppose we have n independent trials, and in each trial the probability of success P is remains same, and the probability that there are X failures preceding the first success among the n trials is given by Q power X into P, where P and Q are related by Q is equals to 1 minus P. Now let us see the definition of geometric distribution. A random variable capital X is said to have geometric distribution if it assumes only non-negative values. A random variable capital X is said to have a geometric distribution if it assumes only non-negative values, and its probability mass function is defined in this way. P of X is equals to probability of capital X is equals to small x, which is equals to Q power X into P, where X varies from 1 to 0, 1, 2, and so on, and P lies between 0 and 1, Q is equals to 1 minus P. P lies between 0 and 1, but remember that 0 less than P less than or equals to 1, and Q is equals to 1 minus P. And P of X is equals to 0 otherwise, where P is the parameter. So a random variable capital X is said to follow the geometric distribution if it assumes only non-negative values, if it takes only non-negative values, and its mass function, probability mass function, is defined in this way. P of X is equals to Q power X into P, where X varies from 0, 1, 2, and so on, and P and Q are related by Q is equals to 1 minus P, 0 otherwise, where P is the parameter. And a random variable capital X follows the geometric distribution with parameter P, then it is denoted by the symbol X follows capital G of P. X follows capital G of P. Excuse me. Capital X follows G of P means capital X is a random variable following the geometric distribution with parameter P. Remember that. There is a note point. Observe that. Since the various probabilities for X is equals to 0, 1, 2, and so on are terms of geometric progression. That's why its name is a geometric distribution. The various probabilities for different values of X is equals to 0, 1, 2, 3, and so on, are nothing but the terms of geometric progression. That's why this distribution is known as a geometric distribution. And also, summation X is equals to 0 to infinity, probability of capital X is equals to small x is given by summation X is equals to 0 to infinity Q power X into P. Here summation runs over X, so P is constant. So you can write the P outside the summation, P into summation X is equals to 0 to infinity Q power X. Now remove the summation, so we get this format: P into 1 plus Q square plus and so on, which is a infinite geometric series, and its sum is given by 1 by 1 minus Q. What is 1 minus q? P. You get p by p. So finally you get 1. Therefore, sum of all probabilities is equals to 1. Summation x is equals to 0 to infinity. P of capital X is equals to small x, which is equals to summation x is equals to 0 to infinity. Q power x into p is equals to 1. That's it. And let us see the next one. Summation x is equals to 0 to infinity. Q power x is equals to 1 by 1 minus q. That is nothing but 1 minus q whole power minus 1, which is the binomial expansion for negative index. Which is the binomial expansion for negative index. That's it. This is the definition of geometric distribution. Define geometric distribution. It means capital X is a random variable which assumes only non-negative values and whose probability mass function is defined in this way. P of x is equals to q power x into p, where x varies from 0, 1, 2, 3 and so on up to infinity, and p comma q are related by 1 plus p is p plus q is equals to 1, and p lies between 0 and 1, where p is the parameter. That's it.